To solve problems number 4 and 5 from AV3 Lesson 3, we need to learn about the segment of a circle. Of a circle is the region between a chord and its intercepted arc. If you take a look at the segment, if you were to trace the radii that go from the center to the endpoints of the chord, this area you could find using this formula for the sector of a circle. But we don't want the whole sector. We don't want this part of it right here, which is the triangle. So we're going to take that formula for the sector and subtract the triangle. Copy this down into your notes. Capital A equals, or the area of the sector, we draw a sector here for a subscript, equals little a over 360 times pi radius squared, subtract 1/2 base times height, where little a is the measure of the arc, and the base and the height are generally the two perpendicular sides of the triangle. So let's take a look at an example. In this example, the arc length is 120. So in the formula, I will replace little a with 120 degrees. The little r, the radius is 13, so I will replace r with 13 squared, and the base and the height of this triangle are 24 and 5. Those are the two that meet at 90 degrees. Oops, I forgot my 1/2 in this formula. So I want 1/2 times 24 times 5. Now, usually we do the exponents first. So we're going to take a look at this and change that into 169. And I'm just going to change the order of the parentheses here and get rid of the parentheses. And I can do that because in this term, all I have is multiply. I'm going to change 1/20 over 360 to 1/3. Then I can put in I can do 1/2 of 24, which is 12. And I know that 12 times 5 is 60. So now, the simplified version of this, if I was to leave it as an improper fraction, or in exact form, I would have 169/3 pi minus 60, and then in parentheses, I would put the whole thing in parentheses with centimeters squared behind it to show that both parts of this are centimeters squared. Let's look at problem number 2 from AV3 Lesson 3. In this particular problem, we're again looking for a sector, but this time we're given the 240 degrees, and we want the sector over here. So if we take 360, subtract that 240, you find out that the degrees of the central angle are 120 degrees. So let's fill that into the formula. Capital A equals little a over 360 times pi times 8 squared. Finish that answer, put centimeters squared behind it, and that will give you the area of that sector.